Okay, simple machines of Pythagorean Theorem. So you should have already watched the first video from before about an introduction to inclined planes. So right now we're going to now take the concept of Pythagorean Theorem and combine it with inclined planes as a way to continue to help you guys get a good math foundation for the high school, which is really important. Okay, so the problem is you have a 2,000 Newton box, you must lift to the next level of the wall. So you have to lift on a wall 2,000 newtons. That's a lot of weight you got to pull up. And again, when you pull up, force goes up, displacement goes up. Everybody, let's assume cosine is 0 right now. For algebra, geometry, algebra students, let's go cosine 0 for this, okay? So 2,000 newtons, we got to find out how far the distance, right? And we know it takes 14,000, so this is the force. We know the work is 14,000 joules. Okay? So it takes 14,000 joules to lift something 2,000 newtons up this wall. Okay? So we need to solve for our distance. So it's easy. Work equals F times D. Again, cosine theta, cosine 0. Again, force upward, displacement upward. The angle between them is 0. Up, 0, not 90. Okay, so we got to solve for D. So we know in algebra, we talked about it so many times this year. We're trying our best to improve this. We need to get D by itself. So this equal sign is a reminder to say, hey guys, whatever you do on one side, you have to do on the other. Everything must be equal. Always pretend an equal sign's talking to you. So when you do this, you're like, okay, I know to cancel that because F divided by F becomes F times 1 over F, like that keep, change, flip thing we worked on. So these cancel out. But again, equal sign's telling you something. What's it telling you? Hey, you divided by F over here, you got to be equal. Do the same over there. Okay? So the equal sign reminds us that whatever I do here, I do here. So this cancels out. So you're left with W over F equals D. Plug it in. Work is 14,000 joules divided by 2,000 newtons equals distance, right? Our answer is 7 meters. 7 meters equals our distance. Okay, so the wall, we have to push this up, is 7 meters. So if I want to get this box up to here, I got to pull hard. 2,000 newtons, only 7 meters. I can't do that. I can't do that. So now we're going to use Pythagorean Theorem. So I'm going to erase this part. But I'm going to keep the wall. I'm going to keep the wall. So watch this. Here's the wall. Wall, we know it's 7 meters. Now wait a minute, it says part B. You decide you need an inclined plane. Okay? Ruler, Mr. Mercer, this is your old ruler. Shout out, buddy. Hope you're enjoying retirement life. Right? Hope you're enjoying it. Here we go. So now we get an inclined plane. We talked about an inclined plane is the shape of a right triangle. And a right triangle means one of the angles is 90 degrees. Okay? So we already know one side or one leg of it, it's 7 meters, okay? So let's see what the problem's asking us. And we know the work to get the job done is 14,000 joules. Just keep that in the back of your mind. You decide you need an inclined plane to help, not do it for you, help you do the work. So you move the box, here's the box, 16 meters away from the wall. Here's the wall. Here's 16 meters. So I have here the base is 16 meters. See how I got a base right there? So now I'm starting right here. The box is going to be right here. So then it says here, how long is the ramp? Well, how far am I going to push? Because I got to figure out how much force I'm going to need, right? See how we're applying the algebra, the math to this. Okay. So this is a right triangle. We're missing a side. This is A. This is B, the base. What's C? Oh, C. This is called the hypotenuse. Do you see the height? Why do I say that? C is hypotenuse, and you can really see it because we talked about it. You can see it. You see that height because why? What do we know about the length of a hypotenuse in a right triangle compared to A and B? It's always going to be the longest, and it's across from, right, from the right angle. So we got to solve for C. So we have a formula. A squared plus B squared equals C squared. And you know these are exponents. So now I'm given 7 squared plus, 16 squared equals c squared. What's this? It ain't 14. 7 times 7 is 49. And I actually prepared an answer key for once, so for speed, right? 16 squared, we taught you how to do it in the calculator. But I will say this, you should know your perfect squares at some point, if not already. Maybe at some point there's like a table of squares, cube roots, fourth roots, fifth roots, you name it. You're going to need to know that. For real, man. I'm like, seriously got to know that. 16 squared is 256 equals c squared. I'm going to bring this guy up here because I'm running out of room. So now I got to simplify. 49 plus 256, I get 305 equals c squared. Okay, so wow, I see the height. It's 305. Right? 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 305 is the biggest side. No, it's wrong. Think about it for a minute. Number one, we said C is the biggest length, hypotenuse, no doubt. But look for a minute. This is 7, this is 16. This doesn't look much bigger than that. How can that be 305? We must have forgot something. Sometimes you have to think the problem, not just do it. Think. Oh, it's because C squared is 305. And that equal sign is saying, oh, it's equivalent, C squared is that. I don't want C squared. I didn't say C squared the height. I said C the height. It's not 305. So what do we got to do? Got to get rid of the exponent. But equal sign is telling me what? What does the equal sign tell us? Whatever you do on one side, well, hold on, what do I do? I need to get rid of it. You take the square root, put a radical. Oh, radical! Radical! Right? They're kind of important. Square root. So watch this. Can I break down C anymore? No, it's C. But this is telling me C squared. C times C. So what's the square root of C times C? C. Do you follow? What's the square root of 12 times 12? So 12 times 12 is 144. What's the square root of 12 times 12? 12. What's the square root of 144? 12. C times C. I'm left with what? C. But wait a minute. See that? No pun intended. The equal sign reminded me, hey dude, gotta do the same thing. So you pop it in the calculator, you're left with 17.5 meters. So the hypotenuse is 17.5 meters, and I gotta be honest, that makes much more sense, because again, it's longer than the base, but not ridiculous. Okay, so again, that equal sign is a reminder. It's there to help you. It's there to help you, remind you, hey buddy, whatever you're doing on one side, you gotta do it on the other. Keep that in mind. That's what they mean by that. Okay. So now I know my trade-off is this. Here's the box down here, right? And now I know work is about the same. It's 14,000 joules. That's how much work. Now we're going to start part C. It's 14,000 joules of work, regardless if I start here, if I start here, right? If I start here, it's going to be the same work. Again, we'll get the friction later. But here's the thing. I'm going a greater distance. Here, it took, what, 2,000 newtons of force to go 7 meters. But notice what I did, my distance went up. So if my distance goes up, I don't have to do what as much? Apply as much force, which might help me. But the ramp makes me still do about the same work. So let's see, part C. It says here, once you find the length of the ramp, how much force do you need to get the job done? Well, you know work is 14,000 joules. How far am I traveling now? Not 7, bigger distance, 17.5 meters. How will that impact the force? Hopefully less, and it will be. That's why it's easier, but still not the same. Formula, W equals FD. Now keep in mind, you guys with the cosine, the force is going this way, the displacement's going in the same direction. Angle theta is 0. The angle theta is between your force and the displacement, not the ramp's angle. This is not theta. This is theta, so it's still 0 degrees. Keep that in mind. It's not the angle of the ramp. It's the angle of the force and the displacement vector up here, just for you guys that do that cosine thing. Okay? So now we got to solve for F. Okay, so I'm going to circle F. And we have our buddy the equal sign. Thanks to equal sign for helping me out through this algebra. Right? So now I need to solve for F. So now what do I got to do? I got to get the D on the other side, because I have to have F by himself. So we know, we've done it before, divide by D, because D divided by D, keep, change, flip, right? D times 1 over D, cancel out. That's why we cancel them. Okay, so, oh, wait a minute. What did equal sign just say? Thank you, equal sign. Thank you for reminding me. Whatever I did on one side, I gotta keep it equal. So I'm gonna do the same thing over there. Am I really talking to an equal sign on YouTube video? Yeah, I am. I don't care. Learn it. Anything it takes, right? Anything it takes to get the job done. We try. Okay. So now we have a new formula. So now with F equals W over D. That's our formula. Now you plug in, right? So I'm just going to flip it. 14,000 joules divided by 17.5 meters. And now my force is only 800 newtons. So instead of going 2,000 newtons up, trying to pull that up, there's no way. Too much. But it's only 7 meters. So again, more distance, I only have to apply 800 newtons. So again, work is about the same. But notice, we just reviewed basic algebra. We just worked with exponents. We just introduced you to Pythagorean Theorem. And the cool thing is, we applied it to real life. And we applied it to science. Okay, so we're going to keep doing stuff like this year and next year. We're starting already, it's going great. And I'm seeing some improvement in the math skills, so we keep it up, because I'm telling you the math is really important. Okay? So you do the other problems, you're getting tested on this, you're going to have a couple of these problems on your test. I hope this helps, and good job. All right, see ya.